Hello students, welcome back to lecture series on linear differential equation with a constant coefficient. Within that we have started last topic from our chapter, which is a symmetrical simultaneous differential equation. I already uploaded method and plenty of the example based on this topic. So we are solving the example based on the method first for solving symmetrical simultaneous differential equation, which is a method of a combination or method of a grouping. Okay, using using variable separable form. Okay, so here in my today's video I'm gonna explain to you all one of the example here using method of combination or grouping method, and at the end we go for applying variable separation form, and then we will find out the solution for our differential equation. Now see that our simultaneous differential equation, which is here as a dx by y square dy by minus xy and dz by x into z minus 2y. Okay, this one is our symmetrical simultaneous differential equation. Okay, so for finding the solution, now as we know that symmetrical simultaneous differential equation has a two solution. Okay, it's just c1 of f of xy, c1 which is equal to f of xyz, and c2 is equal to f of xyz. These are the two different solution. Okay, these are the two different solution. Which are the two solution we have here? C1 of c1 is equal to f of x y z. Okay, this one is first, and c2 is equal to f of x y z. This one is the second solution. Okay, these two different solution we have here for our symmetrical simultaneous differential equation. Okay, yes, let's go for solving this whole symmetrical simultaneous differential equation, and we go for finding the c1 and c2 are the two different solution. Okay, now see that for finding the solution for this equation, we consider any two ratios within these three ratio. You can consider first with the second, first with the third, or second with the third. It is completely up to you. Okay, yes, so what we do here, we consider dy by minus xy and dz by x into z minus 2y. This one is quite challenging, that's why I taken this one. Okay, it's not difficult, it is one of the easy, but you just need to understand how can we go for the substitution. Okay, yes, so first ratio I'm going to consider here dx by okay, so we are going to write dy by minus xy. Okay, dy by minus xy, which is equal to, we compare with this one, dz by x into z minus 2y. Okay, z minus 2y. Try to cancel similar term. Okay, and go for the variable separable form. Okay, as we have dy dz here, so we got the y extra term also, x is also there, y is also, x and z is also there. Okay, yes, try to cancel the similar term. So what we do here, as we don't have x dx, it is not there now, so remove that x from here. Okay, so I'm going to write dy by minus y, that x get cancelled with that x, and dz by z minus 2y. Okay, dz by z minus 2y. Now see that we have dy by minus y, it is okay up to that, but what happen if dz get the denominator is y? Okay, so it is quite difficult for finding the variable separable form. Okay, so in such a case, what we do, we try to remove that y from here. Okay, so in order to remove that y, we just have to go for some substitution or some adjustment in our simultaneous differential equation. Okay, so the adjustment is that dy keep as it is, take the dz denominator, so we write a dy by dz. Okay, dy by dz, which is equal to minus y upon z minus 2y. So what I have done, I taken that denominator to numerator, and that denominator as it is, dy by dz as it is here. Okay, yes. Now see that here we have to go for the substitution. Okay, so we have to go for the substitution in the form of z and y. Okay, now see that y it is numerator, y it is the denominator. That can be easier for calculation or adjustment. Okay, yes, so what we do, we go for the reciprocal from both sides. Okay, so if we take the reciprocal, that two terms goes to the numerator. Okay, as we have numerator it is smaller and denominator it is bigger in the form of terms. Okay, so that's why take this one to the numerator. If it goes to numerator, it goes to the reciprocal for this one also. So I'm going to write a dz by dy. I'm going to write dz by dy as z minus 2y by minus y. Okay, so what I have done, I taken reciprocal from both sides. Okay, so I land here with this step. Okay, yeah, now we go for solving the next step. But now see carefully, as we have z term at the numerator, y it is similar here, we can remove that y easily. Okay, but as we have z term here, so we try to go for a substitution of a z term. Okay, yes, so we are going to substitute, put z. Okay, we are going to substitute the value of a z. So you can substitute the value of a z as y into v. Okay, I consider z as y into v. You can consider anything value. Okay, so as per, it is up to you. So I consider z which is equal to y into v. Okay, so if you're going to replace z as y into v, that means you have to replace dz also. Okay, it is not only for the z, we have to replace z as dz also. Okay, if z is equal to y into v, can we write z by y as v, z divided by y as v. Okay, so I replace z divided by y which is equal to v here. Okay, yes, so what I done, I taken that v to the denominator, y to the denominator, so I got the value for v. As we introduce v here, okay, as we introduce v here, new variable, so that's why we are taking the value for v here. Okay, yes, so if you are putting the value for z, you have to put the value for dz also. So if you are going to put the value for dz, then differentiate z with respect to y. Okay, so you will get the dz by dy here. Okay, so we have to replace this dz by dy also. Okay, as we are going to replace z in the form of v. Okay, yes, so differentiate that z dz by dz by, okay, I'm going to differentiate that dz by dy. Okay, with respect to y. Why we are differentiating with respect to y? Because this entire term we have to replace. Okay, yes, dz by dy. Now see that y into v, it is the term. Okay, so take first term as it is, differentiation of v with respect to y, plus second term as it is, differentiation of y with respect to y, it goes to 1. Okay, no need to write it here. Okay, yes, so I got the dz by dy. So replace this entire term here. Okay, replace this z also. Okay, and now see that which is the next term, next step it is coming. Okay, dz by dy, I'm going to write dz by dy as a, so this put it here. Okay, this step put it here. Okay, so I'm going to write next step as a y into dv by dy, dv by dy plus v. Okay, this entire term I replaced here. Okay, which is equal to, what is the value for z we replaced, we are going to replace here, we consider z as a y into v. Okay, yes, so what we do, first of all, we go for replacement of a z. Okay, so what is z? Z is a y into v here. Now see carefully here, we do not want that, we do not want here that y here. Okay, so we have to take y out from that denominator, so it will be also going out from here. So what we do, we take y common from first two terms. Okay, z minus, we are doing adjustment here in the first this step. Okay, take y common from here, so y common here, z by y minus 2. Okay, z by y minus 2, and denominator we have already minus y. Okay, so cancel this y with this y. Okay, cancel this y with this y. So what we do right now, so we go for substitution of the value. Okay, yes, minus it goes to be here. So what is the next step it is coming? Okay, let me write next step here, y dv by dy plus v, which is equal to y got cancelled, minus of a z by y. Okay, minus 2. Okay, minus of a z by y minus 2. Okay, now what we do, we go for the replacement of the value. Okay, so replace the value for z here. Okay, what is the value for z? Z is the value we have here, consider z as a y into v. Okay, replace here, minus of y into v divided by y minus 2. Okay, so that y we can cancel it here. Okay, yes, we can cancel that y from here, so we write y into dv by dy plus v, which is equal to minus v plus 2. Okay, minus v plus 2. If you are going to multiply that minus sign, okay, minus sign under bracket here. Okay, let me check the negative sign. Yes, z negative sign for this one only here. So we write minus v plus 2 here. Okay, so I multiplied that negative sign under bracket after cancellation of the terms. Okay, minus v plus 2. So what we do, take that v, it is to the other side. Okay, and keep y as it is, as we are going to go for the variable separation now. Okay, y into dv by dy, which is equal to v to the other side, it is minus v minus 2v plus 2. Okay, minus 2v plus 2 it the next term. Okay, because plus 2 it is remain as it is. Okay, minus it gives us the plus 2 value. Okay, yes. So what we do right now, we go for the adjustment of the term. Then next step, try to take v term together and y term together. Okay, minus 2v plus 2 take here, it become denominator. So dv by minus 2v plus 2, okay, which is equal to take dy here, y denominator here. Now see that using variable separation form, I arrange the term dv upon v and dy upon y. But as we have constant v, 2 same here. Okay, so take constant out from here. So I'm going to write 1 upon 1 by 2 totally outside under bracket, dv by v 1 minus v. Okay, 1 minus v, which is equal to dy by y. Okay, dy by y. Now see that we do not want dv and dy, so apply the integration to the both side. Okay, apply integration to the both sides. So 1 by 2 integration of a dv upon v minus 1, which is equal to integration of dy by y. Okay, yes. So we go for the next step. I hope you all have understood this, my last step. Okay, this one is my last step. I will write that last step again here. Okay, so what we have last step, 1/2. Let me write that last step here again, 1/2 integration of 1 upon v minus 1 dv, which is equal to integration on 1 upon y dy. Okay, yes, 1 upon x has integration log of x. Okay, yes, what is the integration of 1 upon x? This is the log of x. You can take like this, or f dash upon x upon f of x. Integration of f dash of x upon f of x, it is a log of f of x. You can apply that result also, you will get the next solution. Okay, yes, 1/2 as it is out here, 1 upon v minus 1 has log of v minus 1 integration with respect to dv. Okay, and 1 upon y has integration log of y. Okay, and as of integration we add a constant first c1. Okay, this one is our first constant c1. Yes, so what we do in our next step, we take that 1 by 2 to the power v minus 1. Okay, then it is easier to operate the next step. So log of, by exponent rule, you have to apply log exponent rule for this one, log of v minus 1 to the power 1/2. Okay, which is equal to log of y plus c1 here. Okay, yes, log of v minus 1 to the power 1/2. That means a to the power x. Okay, log of a to the power x can be written as x log a. Okay, this one is the exponent rule I applied here for solving this step. Okay, yes, and any number to the power 1 by 2 means it is a square root. Okay, square root of v minus 1, which is equal to log of y. Okay, keep as it is, plus c1. Okay, plus c1. So keep c1 as it is, log of c1 or c1, both are the similar term here. Okay, yes, both are the similar term. So now see that we have to remove log from both sides. Okay, so then you will get the function in the form of x and y, simple function in the form of x and y. Okay, and we have v also. We do not want the answer in the form of v, as we have function in the form of x and y. So always remember guys, give the answer in the form of x and y. Don't go for that substitution as it is. You have to replace that value v, but not right now. We are going to replace at the end. Okay, yes. So what you do, apply exponential e to the power log of root v plus 1. Okay, yes. So if we apply log exponential to the both side, we will get the square root of v minus 1 this side. Okay, and the other side what we get, so c1 can be written as log of c1. Okay, you can see that log of c1 it is also constant, and c1 it is also constant. Okay, so both behave same here in this function. So log of y plus log of c1. Okay, so what we do, log of a plus log of b, we write log of a into b, that means log of y into c1. Okay, I'm going to write it as the log of y into c1 here. Okay, yes, log of y into c1. So I'm going to write, let me write log here also. Okay, now next step we are going to remove that log. Okay, so we remove log from both sides, v minus 1, which is equal to y into c1 here. Okay, yes, this one is our next step. Now we don't want the answer in the form of v. Okay, so replace v from here. So we are going to replace v. Okay, so what is the value for v right now? We replace v as a z by y. Okay, so we are going to write a z by y minus 1. Okay, z by y minus 1 is equal to y into c1. Okay, so we do not want that y also to this side. Okay, so you can take y here, as it is a multiplicand, it goes to the denominator. Okay, square root of z by y minus 1 upon y, you can write this way also, or 1 upon y square root of z minus 1. Okay, 1 upon y square root of z by y minus 1. Okay, which is equal to c1. This one is our first f of xyz, which is equal to c1. Okay, this one is our first solution for our given simultaneous differential equation. Okay, now see that it's not difficult, but just whenever we get the two variable at a time now, it is quite confusing. Okay, but not difficult. Now let's go for the next part. We got the c1 only, as it is a simultaneous differential equation, that means it gives us the two different solutions. Now see that we have given differential equation, simultaneous differential equation, dy x by y square, dy by minus xy, dz by x into z minus 2y. Okay, yes. So what do we do? Consider any two. Now we consider first and third, because third is quite challenging, that's why I consider. Now it is one of the easier to find out the solution using first and second. Okay, now let's compare ratio. Okay, compare. Okay, I'm going to write here compare ratio. Okay, first two ratio, dx by y square, which is equal to dy by minus xy. Okay, this one is the ratio I consider here, dx by y square is equal to dy by minus xy. Okay, now see that similar term cancel, that square cancel with this y, so we left here with the term dx by y, which is equal to dy by minus x. Okay, yes, this one is the remaining term here, so it is easier to solve. Okay, take similar term together as a variable separable form. Okay, so dx minus x dx, which is equal to y dy. Okay, as we want in the form of a solution in the form of function, so apply integration. So integration of x dx, which is equal to integration of y dy. Okay, integration of x minus x square by 2, integration of y square by 2 plus c2. Okay, yes, I consider next one as a c2. Okay, so yes, so take y square by 2 this side, so minus x square by 2 minus y square by 2, which is equal to c2. Okay, this one is our next c2. So 2, it is a denominator, so take minus 1 by 2 common here and take to the other side, so minus 1 by 2 common here, x square plus y square, which is equal to c2 here. Okay, so minus 1 by 2, it is multiplicand, take to the other side, we write x square plus y square is equal to minus 2 times c2, and c2 and minus 2 times c2 both are the constant here, both behave same. Okay, so we write only c2, x square plus y square, which is equal to c2. This one is a c2, so we write f of x y z, which is equal to c2. This one is our second solution. Now see that, guys, this one is our first solution, this one is our second solution. It is not the difficult, it is one of the easy solution, guys. These are the question very much important for your SPPU question paper, so don't forget such a easy question, solve them first to get the higher score. Okay, that is here for my today's lecture. I explained one of the example based on the simultaneous differential equation. Okay, and in our next lecture we go for the next method of multipliers. Okay, we go for solving example using method of multipliers from simultaneous differential equation. Okay, so that's it here for my today's lecture. I hope you all have understood everything here in my lecture. Even after, if you found anything difficult, confusing, challenging, let me know, guys, in my comment section. Okay, I will come up with the similar videos. So thank you everyone, thank you for my today's lecture.